We will start with the first episode of the Video Builder series. And yeah, great to have you guys. You have been around in the Anoma ecosystem for quite some time now. I think you guys are at the forefront of our developers. You've jumped into the specs, you've read the documentation, and you've written a ton of code already. So yeah, why don't you just go ahead and introduce yourself, tell us a little bit about your project, and then we can go from there.
Hi there, I'm Amin. We co-founded Swiss Dao like 3 years ago. We are a dev-oriented builder community based in Zurich, Switzerland, bringing all nerds and devs and artists together to build cool stuff and code and products. Web3 focus, of course. And yeah, we have this project here. We unfortunately need to change our name because we got trademark bans on Twitter. So we used to call it Kinklink, and now we need to find a new catchy name for the project we're working on.
Yeah, I'm Michael. Been here working with Amin for a while now. I think this was the first project that we actually worked on. We did a small hackathon before in the Solana ecosystem, but this is the one that was actually proper because the other one was remote, and I generally don't like to consider those too much because they're not as much fun and they're not as engaging. Yeah, and we have been kind of ideating on this project pretty much since then.
A year now.
Yeah, and well, we came across Anoma, and that kind of reignited, I suppose, the project. My focus is on agentic systems. That's actually what I started working on when I came into the space, and I'm still working on this.
And I'm more on the DeFi MEV frontier myself.
Yeah, so together we're currently building a generalized framework for autonomous intent-based matchmaking that applies to diverse domains like dating and the job market.
That's awesome. Can you guys tell me a little bit more about what you're building in the sense that what type of problem are you guys solving and how are you solving it?
So we have like traditional matchmaking systems, which often fall short in two key areas, like in automation and privacy, I'd say. Well, in dating apps, for example, users have to manually swipe through profiles, often revealing way too much data and information about yourself to everyone in that certain pool. So our client agents represent users, automating the matchmaking process so that the agents conduct private conversations on their behalf. Like, let's say, take an example. In the job market, candidates would share their CVs with all recruiters and companies, and indiscriminately, even if there is no genuine or exact match, our agents will ensure that no sensitive information is leaked, such as resumes or contact details. It's only exchanged then with whenever there's a mutual match and it's confirmed, for example. Or on privacy.
Yeah, privacy is thus the other big thing here. So in dating platforms, there you can see whatever user shares. So you need to express your preferences and personal data. Similarly, in recruitment, your details are broadly distributed, regardless of whether the other party is interested or whether there's compatibility. So even when you go ignored, when there's not a match, they will still have your resume, your personal information, which is rather sensitive, I would say. Um, then, yeah, our approach here is to leverage private autonomous agents that negotiate and interact without exposing this sensitive information up front. So only when there's a mutual match, this information might be shared. And it's actually up to the user what they decide to share then as well. So the idea being that you can provide data to your agent that helps the agent represent you better. And then when there's the match, it's not like now all the data will be shared. You can selectively share information that you want to share. So you can even have particular preferences that you keep secret even when there's a match. I will get into that in a bit. And then I think lastly of all
Like a
here is
matchmaking transparency as well. Like you have a separate set of non-client agents, like the matchmaking service itself, which act as solvers of those intents we are broadcasting. Every intent, like every match, starts with an intent, of course. So these agents work together in using a consensus-based mechanism, ensuring that the matchmaking process is fully transparent, and an important contrast to the opaque algorithms that we have out there already of traditional platforms. They might be efficient and faster, but they do not serve or fulfill those criteria we have to them.
Yeah, so just to be a bit more specific here on the actual implementation that we're working on, which consists of two parts. We have the client agents that we've just briefly referenced, which represent users. And then there's the matchmaking system, which consists of a separate set of agents. And that actually is a multi-agent system that collectively does this intent solving. And that also allows it or us for that to be fully transparent. So this is how you can actually know what is happening there, what the algorithms are that this intent, this matchmaker is running. Yeah, so that is a fully decentralized system of agents doing this matchmaking.
That's really interesting. Any more details you want to provide on the system?
Yeah, sure. Is there anything in specific? Let me think for a sec. So effectively, well, the intents are core to the system. As we're talking about matchmaking, we realize that, well, effectively what we are trying to express are intents, and we're trying to match intents, except it's across a very different kind of use case than the one that's generally seen, like trading. So in this case, we have a bunch of things to consider because we're not actually exchanging resources. Like we're matching intents, but these intents that you have, for example, the features that you have or the preferences that you have that we need to match, these you don't exchange with the other party. They remain yours. And another interesting thing to consider here is the fact that you might have preferences over other people's preferences, which is something that I think is generally not considered so far. But it's really important when it comes to this kind of matchmaking situation, because this is kind of an example that I like to use because people can relate to it, I think, quite well. Like, even though you might be well endowed in terms of your finances, you might not want to match with a gold digger. So how do you prevent that? Well, this typically not a label that people wear. However, with meta preferences, you can express that you don't want to match with somebody who is only interested in matching with other agents that have at least a certain amount of wealth. So you can set that kind of a criterion and thereby filter out people that have such preferences themselves. So that is another really interesting and important part.
Maybe one of the things I'm personally really looking forward to on the Anoma side is also seeing the shielded intents, like just what enhanced privacy would get with them. So like the shielded intents would basically allow also users to engage in matchmaking using all sort of sensitive data and information, which will remain encrypted even from the matchmaking service itself. So when two agents would establish a mutually positive match, an example like a high matching score, we would be evaluated. The users then can choose what further information like contact details or resume data or whatever preference they personally have, they could then share. And they can also control and ensure that the data is only exposed and shared if both parties are comfortable and agree on the terms and conditions in that sense, which would be really fascinating to see with the intents in the future.
Yeah, yeah. And what is particularly interesting, I think, is these shielded intents allow you thus to express certain preferences, even though you might not want to share them in person later on, but in a manner that they can be used for matchmaking without actually revealing any information to the matchmaker. So it's a really nice way to, well, to give people the ability to express their actual preferences. If you think about certain countries, for example, where people having particular preferences in dating, well, it's simply not allowed for all sorts of potential reasons. Could be religion, could be a particular kind of government that's in place that just doesn't allow you to express yourself freely. Now you can still express those preferences in a way that, well, it remains private to yourself.
That's super interesting. Now, we've already touched on preferences a few times now. Can you guys describe how preferences in your system relate to intents? And maybe even how intense or the preferences in your system enhance the user experience. How does that work?
So without wanting to go into too much detail on the actual implementation, I suppose, so effectively what we need to do is translate the preferences that users express for particular attributes, for example, or categorical preferences that they have, let's say artists or whatnot, into a linear programming problem. So that is the fundamental level where we need to get at, and it's not entirely trivial, but it's also not as complicated as I first thought. Because effectively, a lot of things already live on a linear scale, whether it be continuous or discrete. And things like categorical data, you can effectively also express on a continuous scale. For example, from 0 to 1, from -1 to 1. If you think about a particular feature that you might have or not. Well, it's simply 0, 1, obviously. If it's a particular feature that you have a certain amount of, let's say you have a language, for example, like you do not just speak English or not, you have a level of proficiency. So we can add that there. So instead of having a 0, 1, you could express it on a scale which is continuous. And then lastly, and when it comes to preferences, you might have negative preferences for things as well. So you want to express also negative values there. So yeah, those kind of categories where you want to express a negative preference for, you can simply encode on a scale from negative to positive 1 in that case. And that allows us to then construct, well, effectively this problem in a linear programming compatible way, which is exactly what Anoma needs to operate.
That's super interesting. And especially because I guess many people still think of intents more in the sense of swaps or cross-chain transactions. But maybe it's worth diving into how your system differentiates here and how intents are important for the use case and solving the problem specifically. Maybe by zooming out a little bit, how are intents used to model these preferences on a higher level?
Yes, I can definitely try and give that a go. So I would say, well, what we consider to be preferences are in the Anoma language called resources. So I think that's important to make clear. And one of the things that you have in dating, for example, or just in a job market, is that let's go with the job market example, you're looking for candidates with a particular profile. And you might want to express that let's say it's in terms of seniority, that you're looking for junior developers, but you're also interested in managers, but you're not interested in senior developers because you have plenty of those. Well, that would be a particular kind of preference that you could express using the intent system, where you say, look, I want this person to have either that kind of level of expertise or the other level of expertise, but not whatever's in the middle. And similarly, so, well, in dating, for example, you might express that you want to match with people that are either very athletic or that have a particular degree, let's say. Like there's often a set of features that are attractive or considered attractive, and well, no person needs to have them all per se. You might want to express that you want a minimal set of those. And these kinds of things you can express in a based system.
Great, thank you. Maybe we pivot to how you guys started building with Anoma. Can you maybe first tell a bit of your personal background, how you started building in the space, perhaps, and then how the paths with Anoma crossed?
Sure. Well, I think it was last year we went like on a hackathon spree, like did like, how much was it, like 10, 12 in like 2 or 3 months, different hackathons around.
Too many? Yeah.
Well, way too many, yes, definitely. And like we built this like during Eve Berlin at Berlin Blockchain Week at the end. later on, I recall a priori, you guys invited us to speak in Brussels, and I chatted with a priori after, and we're talking about intents and the specs and what we could do. Kind of was a hook that caught me, and I was like, Michael, we got to build on this. We got to give it a try, test it out, and try it out. So, long story short, that's how it went. Kept deep digging into the specs, asking questions, hacking around, still fighting with the bash scripts here locally, but like on the setup, that's something for other call. But yeah, that's how we kind
Yeah,
of got more comfortable, got great support on the Anoma side,
yeah,
integrating.
it seemed to be a good match really, because what we were building, we had this privacy preserving feature in mind, but it turned out to, well, it's definitely not trivial. And then, well, the idea was to have private conversations between two agents, like peer to peer. Even the user, the operator of the agent, the client that's being represented should not be able to peek into that conversation. That was the idea, and we tried to leverage a particular technology, which I won't necessarily reference by name. But yeah, basically that didn't work at all. So we ended up settling for simple peer-to-peer communication between the
Yeah.
two agents, which was well, not privacy preserving, but yeah. So we didn't really have the ability to address that. We made that really much, very much a secondary concern, even though it was kind of important for the actual idea, for the actual pitch. And then when we came across Anoma, this seemed to kind of exactly match the thing that we were trying to do. And then the fact, the added benefit of these shielded transactions just provided us with sort of an easier way to achieve at least a certain level of privacy preservation. And we still want to work on the private communication between the two agents. We still are, and there's loads of room there to, loads of space there to explore. But yeah, it allows us to basically, what is the word, to get it quote unquote for free. Like if we adopt the intent base, or if we adopt Anoma, then we will get shielded transactions. And well, it already provides us at least a basic level of privacy on the expression of the intents themselves. So yeah, that's just a really, yeah, that seems really good to us.
I mean, like, yeah, as Michael said, getting matching done and figured out, that's actually straightforward. Versus for privacy, naming privacy is the hard part, and like it is really not straightforward nor clear overall if you would just do it by yourself. And yeah, that's why we decided to build with Anova in the first place, just to have that extra component on top of it, so we can manage it fully end to end.
Yeah, it was just a really interesting thing because I never thought of the system as an intent-based well system with solvers and so on, and that also leads to certain complications that we had to address. Like for example, the solvers in our system will be a collaborative set of agents, at least certainly at the start, because of the fact that we cannot a priori establish what the optimal solution is because we don't know. Why not? Because apart from, well, we could do it using only the information expressed in the intents. But if we want then the agents to communicate and actually score one another at the end of that conversation, that is the actual score that when we aggregate all of those provides us the answer to how good a particular solution was. So we cannot, in the traditional sense, have a competitive system because we cannot decide a priori which solution is the best. So we would need to execute them all, which is prohibitive. It's simply prohibitive. But yeah, there's a trade-off there because of the fact that we adopt this model of collaborative solving with the agents. We can also make it fully transparent, and we can even make it permissionless, which means that although, yes, all of them are running the same kind of models, at least initially that will be the case. So there's a trade-off where, yeah, there could be systematic bias, there could be systematic error, but the on the flip side of that, we can offer transparency, so everybody can know actually how the solving is done, which I think is actually rather interesting.
Yeah, because some solve networks have it. I have intent solved by anybody because you are transparent and you're shielded as well. You're secure.
Yes, and you get this fault tolerance because generally in the competitive systems, if we look at those thus, which yeah, that exist. If you think about Keeper Network, or if you think about intent solving, or any solvers, basically, they have their proprietary software that they're running. And if you're not able to compete, you're simply going to stop competing. So you get this winner takes all kind of a system where you don't know even how many people are actually independently operating in this space. And well, if there's one person in the end that's doing it all, we have centralization in the system. When they fall over, well, this is exactly the thing that Web3 is meant to solve. So therefore, we opt for this collaborative, decentralized solution.
Great. I think one point you just mentioned that, in my personal opinion, gets overlooked a lot when we talk about intent-centric systems is this aspect of counterparty discovery. And I think in many cases we just focus on the sort of the downstream effects of the counterparty discovery, which is user experience improvements. You can express things in a declarative way, and then the system is taking care of the matching. But this, in your application, if I understand it correctly, this matching aspect is this counterparty discovery aspect is really key, and getting this counterparty discovery a component done in a privacy preserving way is like the cherry on top, even. And yeah, this is an aspect that makes the Anoma system very special to me personally. But I wanted to ask you about this specifically. How, and I guess you've already mentioned this a couple of times in different answers now, but how would you say the Anoma system specifically helps you solve your problem? And what parts of the Anoma system do you guys are you actually leveraging to solve your problem?
So yeah, you're right. It is exactly the problem that the focus of our whole application is a counterparty discovery. That's the only thing, because there's not going to be really any swap except for when two users match the information that they decide to swap, let's say, or whatever else. But yeah, that is exactly it. So it has nothing to do with resources in a traditional sense that have an intrinsic value like the cryptocurrencies or so. So yeah, it's really, I think it comes down to a couple of things. So it's the ability to express these intents in a way that they can be solved on a network, like a decentralized network. Now it's going to be a set of collaborative solvers, but ideally we would be able to open this up and we'll see what we can explore there. We still think we have a collaborative solution, but within that framework, different people should be able to use different kinds of models over time. So that is quite interesting. And then it's the fact that, well, this will be transparent to the extent that, well, even though resources might be shielded or preferences might be shielded, it is actually done on a blockchain. And similarly, so with the agents, even though the agents, well, effectively, they're operating also on a local blockchain. Not only can you see whatever they post on the network, whichever network that be, but you can also, they also have a communication layer among themselves, sort of a private blockchain, you can think of it as. It's a Tendermint network that they use for communication, peer-to-peer communication, to reach consensus. So that also is quite interesting, since you can actually query these agents and see whether the application is running or not. They will be posting on chain just some general statistics on
like
what
emitting events, data, and like whatever is just required for telemetry reasons or others.
Yeah, they need to report something on how they're operating, but of course not the user data or so on. But they don't really have access to a bunch of that anyway. All that they know is, okay, how many matches did we make? What were the scores that are there? And they can report such statistics so that you can see whether the system is active, whether it's improving, whether it's doing a good job and actually getting matches for people. So yeah, that is, I think, a big part of it. And then what else can I say about that? Yeah, so we have some really interesting ideas about potentially integrating feedback into, it's a bit of it's something we haven't worked on yet, but I do want to mention it. Integrating feedback from the agents into the expression of the original intents. So how I'm seeing this is effectively users express their intents. Part of those might be shielded, but it's really not perfect because well, there needs to be a balanced set of resources on both sides of the equation here. And one of the things that, for example, is impossible is, let's say you have a particular artist that you like, the other party has a different artist that they like. Well, these are different resources in that sense. So they wouldn't match on the basis of that. So no score there. It's not a positive one. It doesn't contribute. But the LLM, which is taking over at some point when the match is made, is going to have this conversation, and it has a fantastic understanding of the world around us, the ontological relationship between all sorts of concepts. And it will be able to say, look, these two artists, even though they're different, they're actually closely related. Like that's a similar kind of genre, for example, or not. And on the basis of this, it can provide better feedback. It can provide feedback and say, look, even though it seemed to only match half of the resources here, we're actually far more compatible than it looks only based on a direct match. So it might return a much better score in that case. And then what we can do is, after we have a large set of these outcomes, so think of this as
Interactions and
interaction matrix, a matrix of a whole number of these agents. Let's assume all the agents have had an interaction for the sake of it. They have reported scores. We have calculated scores from the initial match. Now we can add latent variables, we'll call them, to the intents themselves to help actually more closely match the actual outcomes of the system. So we're not going to tweak user preferences here, because those are the users to tweak, but we can add this additional information of some latent variable, which we don't know what it represents, to more accurately get matches from the solvers.
But also, like, you have a simple feedback loop also to, during queuing up the potential parties or agents we want to match, we can cluster them better on previous data and preferences. We would evaluate by just having meta preferences set on each individual agent and setup, which will also allow us to improve our system and efficiency overall to lead to higher quality, higher scoring in matches, but also, it is more dynamic. The system will be way more dynamic with that as well.
It sounds a little bit like recursive preference matching, in the sense that I mean, I might specify, I don't know, I might specify like I like 2024 sets from the Fusion Festival, and specifically from like a specific stage even, right? So I guess you can derive two different sets of information from this. First, I specified it, so I might care about like the broad category of music, because I could have also chosen not to specify it and specify something else, right? And then what I mean by recursive solving or preference matching is like, this is so specific, but you can sort of roll it up one level up higher. It's like, okay, I like I don't know, techno. I could also, you could branch it out into the like other hobbies category. I like to go to festivals, maybe, perhaps, but it's like recursive in the sense that you could have these enums that go like that categorize these things. And then if you don't find a match on like you might not be able to find someone who likes like the specific set, but you might find someone on a higher level. If you roll it up to some other category, like you might find someone who matches on, I don't know, dance music.
No, exactly. No, you're right about this. So we also obviously considered this and been thinking about this. There's effectively some ontological tree where you can walk upwards to the parent until they have a shared common ancestor, let's say. So even though the fruits are different, they're both fruits, and it's not a vegetable kind of a thing.
Right.
But the LLM is also really good already at doing these things. Like if you ask it such a question, it will also tell you that these two objects that are fruits are more similar than the other thing, because it's not. So it kind of already has learned all of this, and I think solves that. So we don't really, thankfully, need to start generating ontological trees for things or working with them. I mean, there exists some, but there's a lot of yeah, there's a lot of work.
Maybe the only challenge also that if we have a distributed solver network, we need to make sure every solver uses the same LLM, so the tree is more or less similar. Otherwise, that could lead to worsen match results or scores in that case.
Well, yeah. Well, the client LLM is just a single agent, right?
Yeah,
The matchmaker
That's
doesn't necessarily need to use any LLM, I would say.
that's the ontology discussion we had
yeah.
a couple of weeks ago. Let me ask you guys. Let me ask you guys a completely different question. Looking ahead towards the rest of the year, what is something you guys are looking forward to achieving? Where's the project leading from here?
So yeah, that's a good question. So I would say that we have some minimal version of things now. That's pretty good. There's definitely some things that need to be tweaked there because, well, as you know, I suppose when you're trying to get to MVP, not everything is pretty and beautiful, but that's all right. It's not overly complex. It's rather simple, I would say, still. So that I appreciate a lot. So it's really about getting the transactions on the testnet, obviously, and getting them settled, and then keep iterating on this. So at first, of course, it's very simple. It's just exactly matching preferences that we have, but we really, as we were discussing, want to have this system where we can even match when the intents are more complex, or when there's meta preferences, or when there's feedback from the LLM, even though there are different fruits which you couldn't match, there is something here. The score is much higher than was predicted when we have this interaction. So these kinds of things are really what I'm looking forward to trying to integrate, because I do think that this kind of let's call it learning ability is something that's crucial, because the matchmaking algorithm should improve over time, right? These agents should learn, otherwise it's not very interesting or not interesting enough. But yeah, that is what I would say. Although I would say that for an MVP, none of that is necessary yet. Like the feedback is something that can come after. And similarly, so with the privacy, like I really want to have the privacy there, but it's not necessary for the MVP. Like both these things are kind of
It's more about
extra.
demonstrating full functionality of the system. And I do think we are like in a state right now where we have to deal with very low level issues and bugs to make things flow properly. And I think rather big goal would be next to shielded transactions and privacy and everything, would just to be able to abstract this complexity away, so we can move faster, iterate faster, and build more on top of it, or even have other people join and collaborate with us, since it takes quite a bit of like very in-depth hands-on knowledge to work with the stack. Whereas if you're able to abstract it, we will be basically enabling more friends and devs to join on the project and just build it out to like a state where you can move more with it.
Yeah, both that
Yeah,
and
bigger.
also for people to just use it as soon as possible. I
Yeah.
think that's another really important thing. So even though there's a bunch of features that we are working on that will not be there yet in the first version, it's very important to get feedback early on from users. And we have heard a lot of people that are interested in using such a thing. Like the particular vertical that we were targeting was dating in Berlin, and there were a lot of people that expressed interest and that said, "Look, if you need some test users, I'm willing to join and try this out." But yeah, that's going to be really important to us because, well, we have some idea of what people might want, but obviously we don't really know what people want until we try it out and actually collect feedback.
Maybe also like another domain we like I haven't looked into deep enough yet. It would be figuring out if what ways we could integrate trusted execution environments in. I haven't touched the arena well enough, but that could also be a challenge to look to figure out and make the best out of that. Those features and functionality that comes with it.
Yeah, something like this will inevitably, I think, be necessary, or maybe some other technology develops a little bit faster, whether that's some ZK thing or fully more of an encryption kind of a approach, which could be nice, but probably not
Yeah.
going to be it. But if we want actual private communication between two agents, and we cannot expect, at least currently, for every single user to run their own agent locally. That's just not how it's working right now. I would like to see a future like this, but right now that would be prohibitive if everybody would need to run their agent themselves, I think. So yes, but then that means we have operators that could be on VPN, let's say, but we do need to make sure that the agent, whatever data is there, remains private. So if they need to have a private conversation that remains fully private, where the operator cannot snoop, then yeah, we need something like potentially TEEs or yeah, some other solution.
Yeah, this is a great bridge into the sort of last topic I wanted to touch on, which is if we would zoom out for a second again, after exploring what you guys are aiming for the rest of the year, if we're zooming out a bit, what technologies in general are you guys excited about right now and maybe in the foreseeable future?
That's a good question. So I would really like to see the privacy preserving part, the shielded intents resources, as we've already mentioned. So that's a thing in the works. It's we're gonna try it out soon, but that's one thing. I think that would be one of the first things. And when you mention technologies, do you mean specifically for intents, or are you more broadly asking? Because I would say
I
like
mean,
TEs, for example, is one thing I'm really excited about. I haven't looked into them very well recently. I did so a couple of years ago, and then there were all sorts of issues, which is why I shied away from it. But it seems to be moving in the right direction, so I'm very excited about this. But yeah, I would say all the privacy preserving stuff really, what do you say, tickles my fancy. So yeah, whether it's ZK proofs or for the homomorphic encryption, I'm not an expert on either of these two. Um, but yeah, I would really like to see more of this. So it's really, yeah. And I think that is moving. It's sometimes moving a bit slow, it seems, but I think it is moving. And now that there are so many different competing um, approaches, like we have multi-party computation is another potential approach, which of course with agents could also be very interesting. So all of those I would like to see move forward, and as soon as they become a little bit more friendly, some of those at least, I would definitely like to explore integration
I
of
mean,
these.
with also very more matured ecosystem and more accessible tech, that is what we're seeing right now. And that is exciting to say the least, because what has been possible in theory with big effort 3 years ago now is done with like a few clicks, which is really incredible if you think about it.
Yes, yes, of course, yeah. And with Anoma specifically, things there will also become more user friendly. Like it's just if you're the one who is piloting things, well, yeah, that's typical for Web3, I'd say. But well, you need to go figure things out, and well, things maybe documentation is sometimes lacking, or maybe some implementation doesn't look quite ideal. But that's fine. I mean, that's just part of it. But these things will obviously improve over time. The API will get more user friendly, and yeah, all of that. I'm looking forward to, well, to hopefully this will at some point be like a walk to the park. That would be nice.
Mhm.
Yeah.
yeah, I wanted to actually ask you about this as a final question. Maybe we're looking back at this conversation in a year from now, 2 years from now, who knows? And sort of what kind of feedback would you give to us right now, like honest feedback um, about the state of the project? What can we improve? And then, um, yeah, maybe we're looking back at this in a year or two from now and laugh about how how it is right now, or look back and wonder about how good it is already. Yeah, what do you guys say?
I mean, for good DevX overall, and I think what would be really appreciated at this point now will be Dockerization and standardization of processes and flows. It should be like straightforward of setting up a node in the client with a few clicks, just pull a Docker image and run it. Whereas now, which is understandable, it takes more effort in figuring out also the Juby's compiler and all the other parts moving parts need to put it together, which is like, yeah, it is still early, and you guys will definitely figure it out, but that will really or massively improve the overall adoption of the tech. And I think that is also something that comes with time. Other great examples of how it could be leveraged, actually production grade software out there, which shows how it could outcompete or outperform other or existing systems overall. And yeah, that's, what do you think?
No, I totally agree. I think the most important part is probably just to make it easy to get started, to make it easy to get the node to run, to make it easy to get this transaction example, for example, done without needing to kind of sometimes look around for the, well, for example, the last UVix compiler was just one version, minor version newer than the one that you actually need. And well, of course you can debug it. We managed to debug it, but it takes a bit of time, and that is time you'd rather not spend trying to, yeah, trying to set this up in a way that that the thing works. But yeah, I mean these are.
I mean, like, we could build like a scaffold Anoma, like, you know, scaffold Eve to scaffold Eve. Just do scaffold Anoma, and you got it.
That is not a bad idea. I would like that. Yeah, yeah, definitely.
I would love that. I would
Yeah,
very much support that idea. Bring more tooling into the Anoma ecosystem.
yeah, just to simplify developers' lives, to
Yeah.
get a good UX for the developer. Yeah, and another thing which I do really like is the examples that you guys had. You had these kudos examples, which to me, once I saw those, clarified a whole lot. I mean, I'd read the spec and all, but just seeing something much more concrete like that in code as a developer, as an engineer, I really, that is kind of what I like show me the code, and then that works best for me, much better than reading documentation or things on a forum. And then also the fact that there's like this kind of a Python implementation of it, which is very simple to understand, at least.
The notebook, right?
No, I don't. Yeah, it's probably notebooks. But yeah, that well, if you're familiar with linear programming, that's really not too difficult. Otherwise, you can get into a bit of linear programming, and then the fact that you have now these full apps, which also include a version of this, but then it's like not pure Python. Now it's actually a version using Anoma. So that translation between the two really makes it quite nice, I'd say, because you can just put one next to the other. Getting a version of something like Python is really easy to understand. I haven't had no issues setting up a problem and solving intents like that, even in more complex scenarios than the ones presented there. And then translating it is, yeah, if you have an example of how that's done, just really makes your life a lot easier.
Yeah, that was you mentioned the abstraction away of, like, instead of having to deep dive into Juvix itself, having Python interfaces and bindings, just to like significantly increase the dev capacity and how we can build an Anoma, or like rather faster, since yeah, getting a community of people or devs onto new languages takes always time and is definitely challenging overall. Other chains also tried, well, like, I'm not going to mention names, but it takes really a lot of effort to get to that point where you
Yeah.
can go with it.
Yeah, Python is perfect for that. It's certainly not my favorite language in the world, but it's easy. And if you just want to experiment with things and try to get familiar with it, that's great. There's a reason why there's a reference implementation of Ethereum in Python, because it's really easy to understand. And then if you want to build whatever the thing is you're trying to build, and you're done prototyping, well, you can always switch to the language of your preference.
Great.
But yeah, it's actually the fact that users have preferences, but they themselves might not even be fully aware of how well that actually works for them. So one of the things that we can do with the agent-based approach is we can actually check how restrictive your preferences, meta preferences, actually are. So if you say, look, I'm interested only in a very narrow range on a particular feature, it might turn out that you get, let's say, very few or zero matches. And one of the things we can do is actually provide feedback to the user and say, look, you're getting very few matches because you set this thing, whatever the feature is, to be way too narrow. You're excluding too many people. Or vice versa, it could be, look, you're getting no matches, but it's nothing to do with your preferences. You're compatible in from your direction, but yeah, from the other direction, nobody is interested in. Well, you think of some negative feature. Nobody is. Yeah, I don't want to name anything in specific, but yeah, I think that is also kind of an interesting thing, because you don't, in a regular kind of matchmaking scenario, get this feedback. Recruiters don't provide you this feedback either. They don't tell you, like, look, we're not going to hire you. Well, maybe, but generally not. They'll just say, oh, you're not a suitable candidate, or we found someone else, but you don't really know what it is. And yeah, it would be nice to get feedback on this, I suppose. Like, people wonder, like, oh, why am I getting no matches? Well, it could be
Right.
because it's you, because you're very specific. Or maybe in our case, for example, if somebody else expresses, look, I really want to know this thing about the other person, whether they want to have kids or not. And I'm just not providing that information because I just don't because I don't care, let's say. Now, if the other user express like the other person must also want to have kids, well, we cannot match this. It's a constraint violation. So we could provide information and say, look, you simply provided no information on this, but it turns out a lot of the other agents that you're trying to match with actually want to know this. So maybe you could provide this information.
Is this something that you think the Anoma system could specifically help with, like figuring out these bidirectional intents? Is this something you could see?
I believe so.
Do you have some idea how you could realize these bidirectional intents or sort of these feedback loops for your intents?
But on which level? Because it's not going to happen on the low level. That's more with the periphery and the system on top.
No, not necessarily.
Would you go another route?
No, because what we can do with the linear programming is we can add the direction both ways, basically, in the matchmaking. So you don't get a solution only when it's mutual. Of course, that's the only one where we'll actually declare a match. But we can also see that A matches with B, but B doesn't match with A. Kind of a scenario. Yeah, that's the purely constraint-based. And we can relax those constraints, for example. If we see, oh, this user isn't getting very many matches, we could say, well, what if? Or, well, if they're simply missing a feature, then it's really obvious. Like, oh, this is the constraint violation. They didn't specify whether they want to have kids or not. But if it's something else, we could relax, for example, those constraints. Say, look, you're looking for something very specific here. If you were to, well, we don't tell them that they need to increase this per se, but we can tell them like you're excluding a lot of potential matches because you're being so specific on that particular feature. And we can do that on the low level, on the level of the constraints. So the solver could effectively do this. They could change this and see like, okay, what actually is the constraint, or what are the constraints that are being violated, why this person isn't getting so many matches.
That's super interesting.
Thanks for having us on it.
Yeah, thank you guys for joining the Anoma video builder series. And I'm Maurice. I'm representing the Anoma ecosystem today. And yeah, thanks for being here.
Thanks for having us. Have a good one.